So what we are going to focus on today is we're going to step away from the special right triangles, 30, 60, 90, 45, 45, 90, but we're going to start learning about trig ratios. So this is where the trigonometry actually comes into play in this chapter. So the trig ratios we will be studying will only work when we have a right angle. So you cannot do this on a acute angle or an obtuse. It has to be a right angle. So the acronym that we're going to use is SOH CAH TOA. SOH CAH TOA. Each of those letters represent a part of the triangle. So S is the sine, S-I-N-E. Sine of an angle is the ratio. So remember, ratio is when you come up with that fraction A over B or whatever it is. It's the length of the leg opposite the angle to the length of the hypotenuse. So again, this will make a little more sense once we see actually the triangle. So this is the sine. Ca is the cosine of an angle, is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. And then the T represents the tangent. So the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. Okay, so SOH CAH TOA is something that we need to remember. So what does this mean? Okay, so here we have a triangle. This little symbol is theta, and theta is your reference angle. So when we say length of the side or the leg opposite the angle, that's the angle that it's referencing. So sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so if you remember, it's SOH CAH TOA. And each of those sine, opposite, hypotenuse, right? Opposite over hypotenuse. So if you look at your reference angle and you go all the way across the triangle, that is the leg that is opposite that reference angle. If this is a right angle, the side that is always across from the right angle is the hypotenuse. The adjacent side is that side that forms the reference angle with the hypotenuse. So this is the adjacent. Okay, so what we're going to do now is actually, given these values, we have to come up with the fraction. So again, I'm going to write SOH CAH TOA up here. Number one says sine of A, so we're going to use this portion. Okay, so if you find A, this is your reference angle. Sine is opposite over hypotenuse. So if we go from A, we go all the way across that triangle, our opposite value is 24. Our hypotenuse is the side across from the right angle. That one's really never going to change, which is 26. So it says write this in lowest terms, therefore we need to simplify. So if we simplify this, we're going to get 12 over 13. In number 2, it says sine of C, so now our reference angle is down here. Sine again is opposite over hypotenuse, so opposite is 10, hypotenuse still is 26. So if we simplify, we're going to have 5 over 13. Number 3 is cosine. So now we're going to look at the middle segment, which is adjacent over hypotenuse. So cosine of A, which our reference point is back here, is the side that forms the angle with the hypotenuse. So 10 is the adjacent and 26 is the hypotenuse. And this simplifies to 5 over 13. Number 4 is cosine of C. So our reference angle is right here, which is adjacent, which is side 24, and hypotenuse, which is 26. And again, simplified, 12 over 13. The last one is tangent. And tangent of A, which A is your reference angle, is opposite over adjacent. So we're not using the hypotenuse anymore, so we don't need this 26. Opposite over adjacent, which this would be 12 over 5. And our reference angle would change to C in number 6, opposite over adjacent, which is 5 over 12. Okay, so you have to pay attention to where your reference angle is being said, which is inside the parentheses. You figure out what ratio you're going to use by the word that's out in front, sine, cosine, or tangent, and that's when you look at SOH CAH TOA. Okay, so this is, again, setting up ratios. We can also use our calculators with trig ratios, because what that's going to do is find the missing side length. Okay, so you must have your calculator in degree mode. So if you notice, I have my calculator here on the left. So check your calculator now. So what you're going to do is you're going to press mode, and mode is the button right next to the second. Okay, and we need to put it in degrees. So your screen should match this one here. So mine isn't there, so mine's in radians. So I'm going to arrow down so radian is flashing, and then I'm going to arrow over so now degree is flashing and hit enter. Okay, once you have degree, to get out of here, you hit second mode, which is second quit, and now we're back into our normal screen. So if we want to find a value of a trig function, so those, we could use the ratios, so we could do sine of 5 over 12 or whatever we had at the top, or we can find the side length of a angle measure. Okay, so here we have sine of 52. So your sine, cosine, and tangent values are right above like 7, 8, and 9. So sine, cosine, tangent. If we want to do sine of 52, we're going to hit sine and then just type in 52. Not sine, but sine of 52 and close your parentheses. And hit enter. And we're going to round to the nearest tenth, which is 1 decimal place. So this is 0.8. Okay, always pay attention to the instructions because it could say round to the nearest 10,000. Okay, so yeah, that's 4 decimal places, so just really make sure. So the next one is cosine of 19, so we would hit cosine of 19 and hit enter. So you would have 0.9. Okay, next one is tangent of 65. You get 2.1. Okay, try those next 3 on your own. So if you notice, I typed them into the calculator. And so if you have cosine 44 degrees, you have 0.7. Sine of 14 degrees is 0.2. And tan of 30. What we're going to do, excuse my computer, it's being slow as usual, is we are going to find each length that's missing. And it says round to the nearest hundredth, which is 2 decimal places. So the given angle, which is 63 degrees, is our reference angle, and we need to find EB. Okay, so if this is our reference angle, we have across from it is the opposite, right? And then we have across from the 90 degrees, which is your hypotenuse. So which of these SOHCAH has OH in it and that sign? Okay, so we're going to use the SO part. So what we're going to do is we're going to say sine of 63 is equal to opposite over hypotenuse 12.9. Okay, in order to do this problem, what you're going to do is solve for x. So since you're dividing by 12.9, you're going to multiply by 12.9. Okay, so if we go over to our calculator, we're just going to type this in as we see it. 12.9 times the sine of 63. And if we close our parentheses and hit enter, if we round to the nearest hundredth, we're going to have x equals, because those cancel, 11.49. So the length of EB is 11.49 centimeters. Okay, so that's what we're going to be doing. So we have to figure out what we're looking for. So here's FD, right? We're looking for FD. Given our reference angle is this one. If you notice, we have adjacent and hypotenuse, which is going to be cosine. So we have cosine of 39 is equal to adjacent over hypotenuse. In this case, when you have x in the denominator of your ratio, you are allowed to take these two values here, this cosine or whatever trig function you have, and x, and switch their position. Because if we were to go through and solve for everything, that's what would happen. So our new equation is going to be x equals 20 over the cosine of 39. Okay, so in your calculators, you would type 20 divided by the cosine of 39. It doesn't want to go. It's thinking. You're going to have an answer before me. Hit enter. So x equals 25.74. Okay, so for this one, here's our reference angle. We're looking for CB right here. So here we have opposite and adjacent, so we're going to use tangent of 15 is equal to 10.2 over x. Again, since x is in the denominator, we are allowed to switch the trig function and that, so we would have x equals 10.2 over tangent of 15. So over here we would say 10.2 divided by tangent of 15. And to the nearest hundredth, x equals 38.07. Okay, go ahead, start your homework. I will be checking it tomorrow.